too. So the way it works is on the right-hand side, we have an example workflow. We've actually got kind of a couple workflows in tandem here to show you the differences between different things. And we drag and drop, we call these operators. They're like visual programming blocks. We can drag and drop these into the workflow, chain them together to create your toolpaths. So these are our core operators, our most commonly used ones, but you can see we actually have an awful lot really, and these all come together to create something magic. So we create our select our robot for the workflow for the project. We pick our material, which has got various thermal density, cost properties associated to it. And then we also pick our nozzle, so we can pick different nozzle sizes, different nozzle calibrations, different extrusion rates, so it's all automatic. So with all that said, let's actually jump into the workflow. The first operator is a load operator, and this will import your CAD or your mesh into the digital workspace. And we can work with step files, OBJ files, STL files, and DXF files in polyline format. So we have this kind of wall here, or mold. We'll actually reuse this part later. If it's loaded in the orientation that it would be naturally from CAD, but we can use our transform operator just to reposition it. Got an interactive gimbal, we can move it around and rotate it, snap it to the bed, things like that. So we've now repositioned it in a more optimal orientation for slicing, large format printing. And then we can feed that transformed mesh into our slice operator. So here's where you find most of your like classic 3D printing settings, but we also have a lot more in terms of slicing modes as well. So very traditional horizontal printing, which is what we're going to start with, and then we'll go into some of the more advanced ones later. But we can also change our plane of slicing with angular. We can have it change throughout the print with multiplanar, and then we have others where we can use guides. We can slice parts radially. We can revolve around a symmetrical part. We can do non-planar printing, vase, segmented, cladding, and we'll see some of these later. So we can define our layer heights, wall thicknesses, our number of walls, where our bead position is, which is all very important. Infill skins, brims and rafts, etc. And the slice operator will convert your mesh or your CAD into polylines. And we work with the polylines for the rest of the workflow. So you can see here we have all our individual layers. We can turn on a solid bead view to get a sense of how it would look as it's actually printed. So we have our bead thicknesses, layer heights. At the minute, we're in the line type view, so we can see our different line types. We've got our brim, and we have our outer wall. But we can change this to various other views, like printing sequence. So if you're printing multiple parts at once, or parts that have got different stages to it, sequence is incredibly important, and I'll show you an example of that as well. And lots of other views here. We can turn on other important views like our seams, so we can see our starts and stops, our direction of printing, and controlling where these are is also very important because they tend to be an area of material buildup or defects or weaknesses, so positioning these is pretty critical. And we can crop through our individual layers as well. This is about the same level as a one-click slicer at this stage. We slice the part, and then we can feed it into our toolpath where we can assign things like movement speeds, jump settings, deposition control settings, all these types of classic things. We also have safety checks. So for robots, we can look at reach, wrist singularities. We can check workspace limits, axis limits, and we can also look at collision detections. And we'll have a look at a good collision detection workflow a bit later. And the toolpath operator will take all your polyline data and basically turn it into machine data. So we get a lovely kinematic simulation of our print, and we can watch that in real time with the speeds that you provided, or speed it up, drag it back and forth, whatever you want to do. We get some good estimations up here in terms of printing time, material usage. If your material card has got a price associated to it, it'll give you that as well. And then we also get some useful information on what the robot is actually spent doing. So if you have a part that's got lots of travel moves, that can give you useful information to know you can optimize maybe the location of seams, so you're jumping less, things like that. And we get our safety check report, which is good. And then from here, we can download our toolpath, there's any safety checks that you've not completed, it will prompt you to do so, or you can willfully ignore it if you're brave. And it will download your toolpath file. It will be automatically post-processed in the software to be whatever machine language you need it to be, have any headers and footers you need, any other subroutines, different tokens, etc. So it will be a file that's ready just to upload to your robot or CNC controller and just print.